Hi everybody, welcome to the Introduction to Calculus section of the Calculus Guide video series. In this section we're going to introduce some of the concepts and ideas that calculus is based on. So what is calculus? Calculus is the mathematics of change and motion. If we're working with a number of variables and one of those variables is changing with respect to another variable, or if we're working with one or more objects that are in motion, or if we're working with forces that are being applied to an object and that object is accelerating, then calculus is the mathematics that we want to use. Calculus is also a collection of calculation techniques. We can use calculus to solve problems when we express those problems in terms of mathematical functions. So, a little bit about the history of calculus. It was invented to solve the calculation problems and needs of the 16th and 17th centuries. It was developed independently by Isaac Newton and Gottfried Wilhelm Leibniz. Early historical applications included calculating cannonball trajectories, among others. Another was calculating the position of the planets based upon their planetary orbits. So, what can it be used for? There are a wide range of applications that it can be used for. One of these is calculating rates of change. So we could calculate the rate of change of the position of an object with respect to time. Or we could calculate the rate of change of some other variable with respect to time. Or we could calculate the rate of change of a variable with respect to some other variable that's not time. Another application is the optimization of a problem. If we can express a problem in terms of a mathematical function, then we can use calculus to find the possible maximum and minimum values of the possible range of output values of that function. So another application is error analysis. If we have a mathematical function that consists of a range of inputs and it's producing an output variable, and we know the error that's associated with each one of those input variables, then we can calculate, using calculus, what the error will be associated with the output variable of that function. We can also find the length of curved lines and paths. We can calculate areas and volumes, and we can evaluate continuous functions over a line, a path, an area, or a volume, among other applications. So, where is it used today? Calculus is widely used within the fields of science, engineering, economics, and medicine. If a field is using mathematical modeling, then typically calculus will be involved quite significantly. It's also a core component of university STEM courses, so science, technology, engineering, and maths. So if you're involved in one of these courses, you'll typically have a significant calculus component. Calculus is also typically involved in high school and secondary school syllabuses also. So, how does it work? Calculus is founded around the concept of a limit of a function. And the theory of limits leads to derivatives and integrals. And derivatives and integrals can be used to perform calculations and to solve problems. So in this video series, we're going to learn more about limits, what they are. We're going to learn a lot more about derivatives and integrals, and we're going to see how we can use these derivatives and integrals to solve problems. So some of the content that we're going to cover. We're going to start by covering the slope of a line and rates of change. Then we're going to cover limits. And then we're going to cover tangents to a curve and the derivative. And later on, we're going to see applications of derivatives, integrals and their applications, and we're also going to see a lot more. So, a bit about how to use this series. If you'd like to learn about or revise calculus, then watch all of the series from the beginning. So you're in the right place. We're going to cover the introduction to calculus, move on to the intermediate sections, and beyond. If you're already confident with certain aspects and you're seeking help with something in particular, then feel free to go directly to that section. So if you're already really happy with how limits relate to the derivative, but you would like more information about, say, the calculation rules for finding derivatives, then feel free to go straight to that section. On the other hand, if you're happy with both of those areas, but you'd like to learn a lot more about the practical applications of calculus, then feel free to go straight to that section. It's completely up to you. This concludes this introductory video. Thank you for your time. If you find this series helpful, then please subscribe to the channel. Thank you for your time, and see you next video.